Hi, today we'll be exploring the Thale's triangle theorem. What does this theorem exactly state? It says that if A, B, and C are points on a circle where AC is the diameter of the circle, then the angle ABC is always a right angle. We'll look at that with an animation in GeoGebra to prove that theorem. Okay, so here we are. We'll demonstrate the Thale's theorem in GeoGebra. We'll do it with the semicircle first, and the same will apply to the other part of the circle, the other half of the semicircle. We'll start off by drawing a segment first. We'll select this icon here, and then go down below the line. We will select segment. We will draw segment AB. Next, we will draw a semicircle. This icon here will let us draw a semicircle through 2 points, which is the fifth choice below. So I'll select that. Now if I go from point A, B to point A, I will get a semicircle below the segment. But I do want a semicircle above just to make it a little easier, so I will go from point A to point B and draw a semicircle which has diameter AB in this case. Next, we'll pick a point on the semicircle. Anywhere is fine. I will pick one here. Now, just to make sure that it is in a semicircle, what we want to do is slide it along and see that it is sliding along the semicircle, and we can see that it is. Now at this point, we will draw an inscribed triangle inside of the semicircle. So to do so, we'll select this polygon icon and draw a polygon from point A to point C down to point B and close it again at A. So here we have a triangle that's inscribed in the semicircle. Let's find the measure of angle ACB here. So to do that, we'll select the angle icon and go from angle A to C to B. Oh, look at that. We can see that the angle that we have chosen is 90 degrees. Is it always going to be 90 degrees? Well, we can check that by selecting this point C and moving it along the circle. It doesn't matter where point C and the semicircle is located. We can see that we always have a right angle, therefore a right triangle inscribed. And we can actually click on point C here, select Object Properties, and we can click on the animation, and we can see that the point, as the point moves, the angle ACB is always a right angle. The same would happen if the circle were to continue going all the way around. In other words, the other part of the circle, the other part of the semicircle would also contain a 90-degree angle. I hope this was clear, and I hope this helps and demonstrates the Thale's theorem.